Okay, in this example, we're going to use the empirical rule to answer some questions. The graph below represents the normally distributed data set for standard IQ scores. Use the graph and the empirical rule to answer the questions below. Okay, first question says find the mean. Well, we know where the mean is. The mean, median, and mode are all at the peak on the normal distribution. So the mean IQ score is 100. Find the standard deviation. Okay, so they're showing us here, each of these are the standard deviation mark-offs, and you can see from 100 to 115, that's plus 15. There's a plus 15, plus 15, here's minus, 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 so we can find that the standard deviation is 15. And if you want to show over to the side, one way you got it, 115 minus 100, there's 15. That's how we got it. What's the probability that a random person chosen from this data set would have an IQ score between 85 and 115? Well, how many standard deviations is that? Down 1, up 1, right? So that's within 1 standard deviation. Now it says probability, not percent. So the probability would be, that's our, what? Within 1 standard deviation is what percent? 68%, right? So we'll change that to a probability, sorry, and write it as 0.68. What's the probability that a random person chosen from this data set would have an IQ score between 70 and 130? Well, where's 70? It's down 2 standard deviations, and 130 is up 2 standard deviations. So what percent of the data lies within 2 standard deviations of the mean? 95%, right? So we'll change that to our probability notation, 0.95. Okay, in E it says, what is the probability that a random person chosen from this data set would have an IQ score between 55 and 145? Okay, where's 55? It's down 1, 2, 3 standard deviations. 145 is up 1, 2, 3 standard deviations. So the percent of the data that's within 3 standard deviations is what? 99.7%, right? And so we'll move that decimal place 2 places to the left and get 0.997. And the total, remember the total area is 1, so you can see there's not much left after 0.997. Okay, F. What is the probability that a random person chosen from this data set would have an IQ score above 130? Okay, now that's not so obvious. So now let's take a minute and we can label all the different little slices in here, right? So if we know that this is 68%, down 1 and up 1, if I take 0.68 and divide it by 2, I should find out how much is here and how much is here, right? Because that total is 0.68. So when you divide that, you get 0.34. So I know this area is 0.34 and this area is 0.34, right? And there's my 0.68. Okay? So if I wanted to get this area and this area, well, I know the total between the two is 95, but I've already accounted for these two. So let's get rid of those. If we take 0.95, subtract out 0.68, what's left is 0.27. So 0.27 is these two together, because 0.27 plus 0.34 plus 0.34 would be our 0.95, but it's in 2 parts, 2 equal parts. So if I take 0.27 and divide it by 2, I get 0.135. So this is 0.135 and this is 0.135, right? If you add those 4 numbers up, you should get 0.95, because between 2, 0.95. Okay, we've got 2 more little pieces here. If you go out to 3, right, that's where you have 0.997, but we've already accounted for 0.95. So let's take 0.997, subtract the 0.95, see what's left, 0.047, but 0.047 is this plus this. So we got to split it into 0.047 divided by 2 and that's 0.0235. So this little piece is 0.0235, and this little piece is 0.0235. This is always the case for every single empirical rule. This would break down, would be exactly the same. Okay, we've just got these two little tiny pieces in the tails left. So let's see if we can label those. We know the whole thing is 1, but we've already accounted for 0.997, so how much is left? 0.003. But it's split into two equal parts. So 0.003 divided by 2 is 0.0015. So this is 0.0015 and this is 0.0015. Okay, now they can ask me all kinds of questions using these IQs, and I can just add up the slices that are involved. And this one, back to this one, it said above 130. So above 130 would be 0.0235 plus 0.0015, and that's 0.025. This is not the only way to get this answer, but if you're thinking of another way you could have gotten that and you got the same thing, great, you use that method. What's the probability that a random person chosen from this data set would have an IQ score below 85? So below 85, we need 0.135 plus 0.0235 plus 0.0015. Everything below 85. And what that comes out to be 0.16. Okay. In H, it says, what's the probability that a random person chosen from this data set would have an IQ score between 85 and 130? 85 and 130. So that's going to be 0.34 plus 0.34 plus 0.135, right? And that's 0.815. And remember, in your mind, you can be thinking, oh, this could be a percentage. We could say 81.5% of people in this data set have an IQ score between 85 and 130, right? What's the probability that a random person chosen from this data set would have an IQ score above 145? Well, that we have right there on our graph, 0.0015, which as a percent isn't even 1%, right? It's 0.15%. Move the decimal place 2 places, you still have just 0.15%. Not very many. If 4,000 people were randomly chosen, how many would be expected to have an IQ score above 145? Well, we have that probability, right? So we'd say that 0.0015 of them would have an IQ above 145, and there are 4,000 of them. So when we multiply that, we find that 6 out of 4,000 people would be expected to have an IQ score above 145. So we do need to understand the empirical rule enough to be able to answer questions like this. And sometimes the easiest way is to first make your diagram where all the different parts are labeled, and then you can easily answer any kind of questions using the number of standard deviations away and those labeled parts.